All right, we're back. We are Game 2005. That's Game Physics in the fall 2019 semester. We are going to look at template number or version 9. If you kind of go up on your labs, there is a version called V9. I've been fooling around with these problems over section 1 and section 2. Just a reminder for next week, we will be having our exam, our final test, sorry, between this time frame and the time frame during your labs. So that's what we're going to be doing. You're going to have roughly 100 minutes minus your download time, because you have to download the template that I'm going to give you on Thursday, which is going to be a variant of this one. Then you're going to have to put your comments in the code, and you're going to have to upload stuff back to Blackboard, right? So there is no, you have to zip it up and everything else, take the garbage files away. So that's going to remove at least another 10 minutes. So we're talking about 15 minutes away from 100, which leaves you with 85 minutes roughly to do your stuff. Which means if I give you 85 minutes, chances are I can't give you more than one task with a couple of additional subtasks. So that's what's going to happen next week. It's going to be very similar to assignment 3 in terms of difficulty. One thing you won't be asked to do is use standard AABB or standard circle check, collision check. You'll have probably a combination of to get it done. It'll be fairly straightforward. If you've been working, coming into class and practicing, you shouldn't have a problem. That's the idea. I'm going to try and gear it or measure it for about 45 minutes, but 45 minutes for me may not be 45 minutes for you, and depending on your comfort, it may be more challenging. I'm just going to unzip this file. You can find template V9 up on Blackboard as well. I'm going to use this one from last week. So I'm going to just extract it. And of course what I'm going to do here, just like before, is I'm going to cut this out and paste it out here. And then get rid of this, because I don't need this extra layer. One thing I'm also going to do is I'm going to put this up on GitHub for you guys, right, to make it easier for you guys to find this stuff. So again, just like we've done before, I'm going to go to Commands. I'm going to go to CD space and drag and drop section 3 in there. Yeah, I totally do it, yeah. I've been doing it the whole time, yeah. So, no. Drag and drop, man, yeah. So once you've done that, you can, let's just clear, and then what we want to do is we want to get remove origin, because we have an origin that points to another repository. We want to reset the repository to something else. I'm going to go back up to GitHub, so github.com, and we're going to go to George Brown, where I'm going to create a new repo. So again, this is going to be Game 2005, Fall 2019, and it's lesson 14, the last lesson really at the end of the day, right? Once I've done that, I'm going to have these 2 lines of code that I need. I can just copy them and then just right click and then paste them in. And then if I just press enter, it'll connect this project to that repository, which is what I want. So that way, whatever I do now will go into that repository. If I refresh, you can see now that it has all the commits from last time. The only thing is that this needs to change, so I'm just going to change this one, which is the Game Physics lesson 14. And instead of more collision detection, we're going to call this collision response, which is really what this is all about. Well, if I can do this. And because I'm ahead now, collision response is only up on GitHub, I need to pull it. So git pull, which should pull it back down, gives me the new thing. Okay, so now I'm up to date. Yay. Alright, so what I want to do is do 2 things. I want to review the template from last week, really briefly. I mean, we know what we had, right? We kind of created some structures. Did I pull up the right thing? Wait. What the heck? What the heck? That should not have started that way. That should have been like a total new thing, not the way we did it, but whatever. Maybe I don't. Yeah, that's weird. I don't know. Let's see what happens. So I'm going to go back to my Solution Explorer and do a couple things. One is, here's one way of checking it. One of the errors we made last week is the capsule collider one. We talked about capsule collider being a variant. And the other thing is that, sorry, I have to also retarget my solution, which is what you should do every time you get a project from Blackboard, because I'm stripping out, I usually strip out the library, so the garbage files, right? So you should retarget everything. And one thing I know is that this should say circle, which is wrong. It should actually say capsule, so that's the first thing I want to change, because that was wrong last week. Okay, I forgot to do that. But we're not going to use this right now. What I want to do is I want to create a little scenario where I have a ball that bounces off my ship. Okay, right now if you build this thing, what we have is no ball, and we have our ship and our planet. Here's our ship and planet, and we've practiced collision detection techniques, so we can go to the planet and detect collision detection between the ship and the planet, where the ship has a circle kind of collider and the planet has a square, which is kind of reversed, really. I really don't care about the planet in mind in this example, so I'm going to just get rid of them, right? And then I want to change the collider type from my what's being shown from my ship to a box collider, right? So what I want to do is a couple things. I want to go to my scenes. I want to go to my start scene.cpp where I do some of those changes. And I don't want to draw the ship, or sorry, the planet or the mine anymore. We can keep them in the game, but right now I just don't feel like drawing them at all. So they're not going to be drawn. And in fact, I don't want to draw the rectangles around them either. So let's get rid of those things. Just commenting those things out. But I'm keeping them in place. So if I run it right now, now that I've commented them out, all we should see is the ship. But this ship shouldn't be positioned there. Let's position it in the middle to make it easier for us to have this thing happen. So what I'm going to do is on the start, in start, I start my ship at a specific spot, 100 and 100, and I'm just going to change this to, because my screen is 800 by 600, to 400 and 300. Okay? 400 and 300. And if I run this now, you can see that it starts, the ship will start in the middle of the screen. There it is. Instead of making it be a circle, I don't want to show a circle collider in my debug mode. I want to show it being a rectangle. So let's just uncomment this one or comment this one and uncomment that one. Right, so let's do that. Again, now you can see that it's going to show as a rectangle collider, which is what I want. And all I've done is just comment out and recomment this part here inside of your draw function. And then what I want to do is I want to go back to the update. In my update, I update my ship and planet. I don't want to do that anymore. So planet, I don't care about updating that one. We're not even showing it. And mine. And we're not going to do these two CPP checks anymore because they're not going to exist. We're just going to comment those out for now. We're going to leave them in those for reference. Right, so that's in the update function. So we have draw, update, and start. And we're not going to do anything in the start. Start's going to remain the same because I want them to be instantiated like this, just in case you need them. So if you want to put them back, you just kind of uncomment the draw and the updates. Okay? But I want to add a new thing, and we have a game object for this. It's called target. What target does actually is it opens up it loads the circle texture, and a circle texture is literally like a blue circle. That's what it does. So I want to make a new object called bullet, but it's going to be of type target. Don't worry about the name. This was used for another purpose last semester, where we use the circle to have as a target for where the ship would find. We're using pathfinding, but we're not going to use it for that. We're going to use it for a bullet this time around. A big bullet, a massive bullet. So that's target. So what I want to do here in my start scene.h, so if I go to my scenes, and if I go to my start scene.h, let's bring that up, I want to include the target.h, right, there's target.h, and what I want to do with that is down in here where we start doing some planet and mine stuff, we'll also do some bullet stuff. So here's our bullet stuff. I'm calling it bullet stuff, yay. It is a target pointer, which we're going to make, it's going to be called bullet. There we go. It looks like a bullet, but or a little target, a little circle, but we're going to use that as our bullet. All right, so we'll always think about it as bullet. Okay, now we have to do the other work. So now that we've done it in our .h, we have to go back to our .cpp, and inside of our start function, we're going to go in here and just do the same thing. We're going to instantiate a bullet, which is going to be of type m_p bullet, which is going to be a new target. By default, it has a default position where it's going to be on top of the ship. However, we're going to change this in a second. So if I was to just launch this like this, it wouldn't work. I need to also put an update and a draw function. So I'm going to go to the draw, and under the ship, I'm going to just make it so that the target is drawn, m_p bullet draw, right? And then the same thing goes with the update. I want to definitely update the bullet every frame, right? So every frame we're going to say m_p bullet and then update. Okay, there we go. So that's true as well. And then if I run this thing, you should see the bullet on top of the ship because that's the default values for the bullet in a second. And you're not going to see the planet or the mine. You're also not going to see an outline for the bullet because the bullet's circular. So this is what you're going to see. This is the default position for the bullet right here, 100, 100. So what I don't want the bullet to be here, right? What I want is the bullet to stream down in random positions from the top of the screen, or from the left, or from the right, or from the bottom. It's going to come from any direction, okay? And if I have more than one bullet, which is what I'm hoping to get done today, it'll bounce off the ship in the correct angle of attack, right? Depending on where they're coming from. Right now we only have one bullet. So let's go do this. So what I want to do now is I'm going to go inside the target.cpp file. Actually, let's go in target.h first. Target.h, here's target.h. Target.h has a few lifecycle functions that are coming with the game object, but they also have a few functions that come with the actual targets themselves. We have a move, a check bounds, and a reset. They're all private. I want to take my reset and make that public. So I'm going to cut this out, put it in the public area for now. And I'm doing this just for a reason. And I'm going to rename my reset to reset. Instead of m_reset that indicates it's private, it's just going to be reset now. And I've refactored that. Right click, refactor, rename. You don't? 2017. Otherwise, you can just go in here, just rename this reset, and then when you go back into CPP, rename that reset as well. This reset. If you rename it there and here, yeah. Right? Alright, so I've renamed reset to what it's supposed to be. Again, you can do it manually or you can do it like me. I'm using ReSharper, that might be the reason why. ReSharper C++. But, so what I want to do here is going back into the target.cpp, I want to do the following. I've got my move function, and the move function is going to be called every update. Every update, I'm calling move and check bounds, right? So here's move. Move, it takes the position, it adds velocity to it, and multiplies it by 5. My velocity is going to be set to something. Right now it's set to 0. And then it sets the position. I could have done this all in one line, but right now I'm doing it in 2 lines just to make it easier to look at. What I want to do is on reset, let's try this out first. Was that?
For a random variable on reset, right? Like into.
Yeah. So when reset, what I want to do is I want to use the utility function. I built the utility function. Let's go to util. So let's include the util library that I made, util.h, and it's part of your template. And what I'm going to do is I'm going to say something like this. I want to set the position of my bullet every reset to the following. I want to make a new GLM vec2 object, right? And in my GLM vec2, the X position, which is the top of the screen, is going to be a random number between 0 and 800. So 0.0. I want to make a random number, right? So vec2, the way you do that is you go util dot or random range. I've got a random range function similar to the one we use in Unity that goes from, again, 0.0f to 800f. And then on the x-axis, I'm just going to make it so that it is 0.0. Now this is not right yet, but this will set the position in a random place at the top of the screen. Okay? And then I want to set the velocity, right? I want to set the velocity on the x-axis. I'm going to set a random velocity that drifts to the left or the right. So I'm going to set a GLM vec2 object that drifts from the left to the right. So util random range from the left to the right, from -1 to 1. So that's going to be the speed on the x-axis. And on the y-axis, we're going to have a constant speed of 1.0. So it's going to go drop down, okay? So that's going to happen every time it resets. Okay, so a random number between 0 and 800 on the x-axis and 0 on the y-axis, and the velocity is going to be a random speed between -1 and 1 on the x-axis and 1 on the y-axis, which means it's going to drop down. We're going to call this function, but what happens when it gets to the bottom? Well, if it gets to the bottom, I want to do a check. I want to say that if my get position dot y is greater than 600, let's try this one first, then what I want to do is reset. That's what it's going to do. Okay, so it's going to happen there. And if I run this code now, let's run the code and making sure it works. Remember that one thing I'm not ready yet. I have to go back to my start scene.cpp. I'm going to go back to my start. And in my start, when I instantiate my bullet, I'm also going to reset it. I'm going to say that m_p bullet. I'm going to call the reset function, which is going to set a random velocity, and it's also going to set a random position for the bullet, right? If I don't do this, it won't move. And this should be good. Let's see what happens now when I just press play. You should get something that looks like, whenever this builds, well, it's going to get something that looks random, a random position from the top, and it's going to be some random speed from the left and right. Okay, that's what you're going to get. Random for the top. Okay? So pretty straightforward, I think. So just to the top somewhere, and it's going either to the right or the left. Right, so there's left, or left, okay, and there's right to the right, but it's a different position on the top. Okay? Great. So now that's good, but we want to continue with that. I like the idea behind that, but I want to constrain where it appears between, so that it takes into account my width and my height of my bullet, so it's off screen. So I want to say that, okay, well, it's definitely 0 minus half my height, right? Half my height. So I want to say that it's really minus get height times 0.5f. So that's what it's going to be. on that mark. It's going to start off negatively off the screen. Okay, and this can't work, right? Because this is going to be from 0, but that's going to be like on the let's say on the left, but my object is going to stick out on the left hand side. So only half of the object is going to show potentially. So I want to add half the width, right? And then subtract my whole width. So I want to say get width times 0.5, and I want to take my 800 minus get width completely, and that should be the offset. That's including all the offsets now. Oops. So it kind of looks like this. So this will be a random position off screen, but it won't be like before. So if I run it, now you can see that it's going to start on the screen somewhere. You're always going to see it. It's going to start off screen up here, but it's not going to start like half off here or half off there anymore. Right? There we go.
So that's what you're looking for from the
No.
assignment?
No. I'm doing something else so I can show you how to do the assignment. I can't give you the answers for the assignment, right? So I'm going to just do something different, but kind of similar to what...
This is very similar to
Of course it is.
That's exactly the point.
That's the point. It's very similar, but it's not going to give you everything, right? All right, so yes, nice. I like it. This is nice, but I want to make it also so it's what if I want to roll a random die. So I want to roll a d4, a number between 1 and 4, like D&D, right? And if I roll a 1, it's going to come from the top. And it's going to start on the top in a random position. If I roll a 2, it's going to start from the right, bottom, and left, and so on. So let's roll a d4. So I'm going to call this an int, which is a d4, and I'm going to say that I'm going to use the ceiling function, and I'm going to call util random range, and it's going to go from 0.0 to 4. And this d4, if there's going to be, I'm going to switch case it, switch the d4, and I'm going to have several cases. Case 1, then do something. Case 2, then do something else. And case 3, then do something else. And case 4, then do something else. There's all my cases. And the first case is going to be the top. So this is this case. But what if I wanted to make it come from the right? So actually, let's do the bottom first. So top, right, bottom, left. So let's do the bottom as number 3, just in order. So if it's going to come from the bottom, this is still true. Random range from on the x-axis. But instead of this being minus get height, it's going to be 600.0f plus half my height. That's the only difference there. That's for the bottom. So this is the bottom, starting off from the bottom. So I'm adding it, so it's going to start from the bottom. And then the velocity, it can't be a negative, 1. It's going to be a negative 1. So it's going to come up the other way. So that's case number 3. So case 3, it's going to start some random position on the x-axis on the bottom, and then it's going to go negative up. Okay, case number 2. This is from the right. So it's going to change now. So I want to get a new vec2, but instead of the x-axis being random, I'm going to make the y-axis be random. So I'm going to get rid of this. I'm going to put it over here. And what I'm going to say is that if it's starting on the right, I want to take my 800 pixels, right, minus, so it's 800.0f, minus get width this time, not get height, get width, times 0.5. So I'm going to say 800 pixels on the right, and instead of minus, I'm going to go plus, because I should add half a width. So it's outside of the screen on the right. 800 plus half the width. Okay? And then that's on the x-axis. On the y-axis, though, it's going to go up and down, right? So it's going to go from 0 plus half the height. Get height. Okay, 0 plus half the height. And then the maximum is going to be 600, right, minus the whole height. And that's on the right. So it's going to pick a random y location from height, get height, which is, let's say the height is 50. It's going to pick it like 25 pixels down all the way to 600 minus the whole height, whatever that is. Don't worry, I'm going to put this up on GitHub in a second. You don't have to do that. And then, this is different. The random range is going to be on the y-axis, not on the x-axis. I'm going to take this part, cut it, and it's going to go like this, paste it, and then it's going to be a random number that's going to go to the it's going to go from the right to the left. So it's going to be a -1 on the x-axis and a random number on the y-axis between -1 and 1. So the kind of the exact opposite of what I've done there. And that is the right case. So this is, I'm going to name this. So this is top. This is right. This is bottom. And this will be left. So left is like right but reverse. So I'm going to just copy this part and go down here and paste it. And now it's the same on the position. Position is going to be on the top and the bottom. That's where it's going to be. But instead of being on the right hand side for the x-axis, it's just going to be negative get width times 0.5. Right? That's on the x-axis, negative get width times 0.5. And then on the y-axis it's going to be the same. And on the velocity it's going to be a +1. And that's the motion that we're going to have. So that's going to basically say which direction am I going to come from. I'm going to start either from the top, right, bottom, or left. And if I start on the top, I'm going to go down. If I start on the right, I'm going to go left. If I start on the bottom, I'm going to go up. If I start on the left, I'm going to go right. That's what this is. It's going to fire a bullet in different directions. Okay? If this makes sense. So after we've done this, I'm just waiting for you guys to catch up. And again, I'm just going to go one of these like this so you guys can see it all. What's that? I'm going to put this up on GitHub. Give me 1 second. I'll put it up on GitHub for you. You can copy paste. All right, then what? Yeah, sure. So then that's cool, but this check is not good enough anymore, right? The check bounds. We can't just check for the bottom case. We have to check for the top case and the right case and the left case. So let's say, well, if the position y is greater than 600, right? And it's not just 600, but 600 plus half the height. 600 plus get height times 0.5f. So it's this. This is the first case. So it's greater than the height of the screen. Or, second case, if it's greater than to the right of the screen, which is, actually we can do the top. Let's do the top first, because it's the opposite of this. So again, I'm just going to take this. And I'm going to rejig this in a second. So I'm going to put an extra bracket out here and an extra bracket over here. I'm going to say, okay, well, what if get position dot y on the y-axis is less than, so this is that's the bottom, that's less than the top, so less than minus get height times 0.5. So this is like outside of the screen but on the top. So this is the bottom, and this is the top. Okay? So bottom, top. I'm just going to make sure that you see the brackets. Like they're the brackets like this, okay? So the bottom would be, okay, I'm checking for the bottom of the screen, 600 pixels plus half the height of the object, right? That's checking to see if it's past the bottom. This is, okay, I'm checking for the position of the object. If it's less than the negative height, so times 0.5. So if the height was 50, it'd be like negative 25 off the screen, basically. So it's going to pull the whole thing off, right? Well, if it's off the screen, then this should also pass, right? Now we need to do the right and left. And the right and left are the same kind of idea. So we're going to say that or, by the way, it doesn't really matter the order too much, but let's just, let's just keep going. So we're going to say, what if get position now dot x, what if it's greater than 800, right? It's greater than 800, but plus half the width. Get width times 0.5. Right. So if that's true, then it's right side, right? And then we'll do the last one, which is the left, right? I'm doing it this way because they're related, not because is there any particular order here. But we're going to say, well, we're going to say get position dot x is less than negative get width times 0.5, and that's all the cases. So that is left. So we're saying, okay, depending on where it goes, if it's outside the bounds of the screen, well, then it's going to reset. And I'm just gonna put this all back so that you see it in its glory. It should look like, well, this. And what am I missing? It's missing an extra bracket.
Yeah. I think you accidentally commented with the
Okay. So that's how it should look. Right? So this checks everything and it calls reset every time. Depending on what kind of reset we do, we'll do a random reset, and let's see how that works. So what we should see now, if we did it right, is it comes from different positions. So from the top, from the left, from the bottom, from the top, from the left, from the right, from the left, from the left, and sort of from the bottom, and you can see that it's coming up. So it's going to come from different directions. So this is not like the assignment, right? So this is coming from different directions. Yes? No. Who said that? But, okay, so now what I wanted to do, just see how I did there, I wanted to detect the collision. I want to detect the collisions now with all this stuff, right? We know that this is a AABB. That's what we want to do, because this would be the closest to your brick for assignment 3, right? And we know this bullet is a circle. Now, it doesn't have to be. In your assignment 3, you could use AABB if you want. If you made the bullet like squarish, I never told you what to make the bullet look like. You can do whatever you want. You could make it look like a bullet or a missile, whatever you want. But if you're clever, you can make them so that they're roughly the same size. I'm not going to be clever. I'm going to make this a circle, and I'm going to make this a AABB. So I'm going to use that new circle AABB detection thing. So let's put this up on GitHub first to get you guys all caught up. So I'm going to go to Team Explorer, and I'm going to go to Changes, and I'm going to say added bullet that spawns randomly. Commit all. I'm going to go home, sync, and push, and then you should be able to see the changes up on GitHub, so you can have that stuff. Okay, so that you should have all the code up on GitHub now. And if you look up on GitHub, that's github.com/George Brown College, GAME2005 F2019 lesson 14. You should see those changes inside of our source folder, inside of changes we made were on target. So if you look at target.cpp, they're in there. You can see all the changes in my target right here. These are all the changes. You can see them. Okay? So that's where they all are if you want it. Alright, so we've done this part, but we're still quite far off of what we want to do. I want to go into my start scene.cpp, and so we have a couple things, right? In my start scene, I want to go to my update function. In my update function, I want to do one of these checks. And it's not square radius check, it's not AABB check. I want to do a circle AABB check like this, but I don't want to do the ship and the mine. I want to do the bullet, which is a circle, and the ship, which is in a different position. So I'm going to kind of do one of these. Now you don't have to do this. This is the collision detection part. So I'm going to do this M_P bullet and the ship. Now this is not going to satisfy a condition because we never check for ship as object 2, as you'll see. However, we're going to fix this. This is inside update. Inside update in the start scene. I've just commented this out because I've shown you different ways of doing this over the last few weeks, right? So I don't want to take these away. For the exam, the final test next week, I may uncomment stuff just to make it cleaner. Not because I want to hide anything. You still have all my GitHub stuff. You can always look there. You can always look anywhere you want. Next week is open book. Okay? Alright, so this is cool. Yes, I like it. I want to do the circle AABB check. Let's right click and go to definition. So it'll take us right into our collision manager.cpp. You can see what this does. Collision manager.cpp says, I want to get the distance between my circle and my AABB. I check the distance, and that's how I detect if there's a collision between these two objects, right? So we know the collision detection works. One thing I wanted to change is this pattern is the exact same as this pattern and this pattern. It's crying out for a method. I'm not going to do that right now, but it is crying for you to do it, right? So one thing I need to have checked with, object 1 with a planet, object 1 with a mine. Usually object 1 is a ship, but now object 2 is the ship and object 1 is the bullet. So I need another case. So let's add another case in here. And the other case I'm going to add in is ship. I've kind of made so that there's a ship. There we go. So if it's a ship, it's going to make, I'm going to collide with the ship. Yay. I'm going to make the thunder sound play. And let's see if that works. That's the only thing I need to do to check to see if the ship is collided with the bullet, right? Let's run that. If I can actually collide with anything. One thing is my ship is really, really slow. And, oh, here it is. There we go. So the collision detection works. However, I'd like to speed up my ship. I think the ship is really too slow. So inside of the start scene.cpp, under the start, if I go back to start, you can see that I have this speed factor. I'm going to just multiply. I'm going to take this and make it twice as fast for my movement. And then now I should be able to move quicker with my ship. Still not going to catch the object half the time, but the other half I will be able to do it. Okay? I'm going to do that. I'm going to slow down the velocity of the bullet too. The problem with the bullet velocity is it's inside the target.cpp, and it's in here. So if you look at the this one here, it's on the x-axis is -1 to 1. So all this would have to be slowed down to like half, right? Or in the move, instead of multiplying it by 5, let's multiply it by like 2, which would slow everything down. So if I did that, that'll make the bullet nice and slow and easy to catch, right? Okay, so it completely collides. We're good. You can see we can reposition now, and we're going to be good to go. Now, here's the challenge for today. Can we make the bullet, and this is the challenge we had, bounce off the ship, knowing that the bullet is a circle and the ship is a rectangle? That's what we made, right? And bounce in the right configuration order, right? So one thing we know for sure, and this is something we can try, this is going to happen in the collision manager. So we know the ship collided with the bullet. Here, we know it's happened, all right? So in here, we know a couple more things. We know that we can detect which side the bullet collided with. A bullet collided with the ship. We can figure this out by subtracting. We can get the deltas on the x and the y side to understand, the difference in x's and difference in y's will tell us which side the bullets collided on the right side, or the left side, and so on. We need to do this because we're going to use dot product next. So up here, I'm going to make a couple more variables inside of my circle AABB check. I'm going to make one that is going to be, I'm going to do it here actually, int half box width. I'm going to make it box width times 0.5. I'm doing this because I don't want to have to calculate this over and over again. And again, half box height is going to be equal to box height times 0.5f. Oh, okay. So that's going to set that up there as well. So those are a couple new things. I also want to get a vector. In order for me to use my dot product, I'm going to need to get a vector between my object 1 and object 2, so between my bullet, and just to be clear of what this means, I'm getting two objects here, object 1 and object 2. But guess what? Object 1 is going to be my bullet this time, and object 2 is going to be my ship, right? So I want to get a vector between these two objects, almost like a line that I'm going to draw from one object to the other object. So in order for me to do that, I'm only going to do that when we collide. So when I confirm that the collision is happening, so in here around line 183, right? Just before the switch case, I'm going to go in here and say float. I want to get a vector between the two, right? So it's not a float actually, it's a GLM vec2, right? And the GLM vec2 that I want to get, let's think about what we can call this. We need a vector. We need some kind of line that connects the two objects, almost like a, call it an angle, kind of an attack vector. Okay, so we're going to call this attack vector. Attack vector is going to equal to the differences in the position. So we're going to get object 1 dash get position minus object 2 get position, and then we're going to get a vector which is the attack vector, whatever that is, the difference between the two. We're going to take two vectors, we're going to subtract them, we're going to get a vector between the two of them. Once we've got this attack vector, what we want is to get the attack angle, and for that what we're going to do is we're going to use the dot product. Now inside of the util function I've got the dot product. So notice that here I'm using util, right? And what I want to do is I want to use the util to get the dot. The dot is going to be a floating point number. So I'm going to say float my dot, right? To be honest, to be clear, we can call this attack dot or whatever, but basically it's the dot product between those two things. In order for me to figure this out, I need kind of a normal. So let's do a normal first, actually. Let's do a normal first. So the normal is going to be GLM vec2. We'll call this normal. The normal we're going to use is a new GLM vec2 object, right? And the new GLM vec2 object that we're going to create is going to be from 0 on the x-axis to -1. 0.0f to 1.0f, which is going to be -1. So this is going to actually draw a line from the object, and I've kind of drawn it out a little bit. let's take a look at the sketch I made. So here's a sketch. I've got my ship, and I've got these lines of attack, let's say, right? You can see that there might be a line of attack here, here, here. And I can break this down into different quadrants. What I'm looking at is a normal is going to go from here up. -1 means it's going to be pointing in this direction. So I'm actually going to take a normal that's pointing straight up like this. That's the normal vector. Oops. That's the normal vector. It's going to kind of go like this. But it's going to be normalized because it's from 0 to -1. Why -1? Because north in our case, so I'm going to put north here. So north, from a cardinal direction perspective, is our 0, 0 point. So this is 0. Okay? If I go towards the right, there's an angle, some kind of positive angle, all the way to 180 degrees. And if I go to the left, there's a positive angle of another 180 degrees. This way. Okay? So this is what we're going to be doing. So we got the normal. We got the attack vector. Right? Now what we need to do is we need to get the dot product between the normal and the attack vector. Okay? So we're going to say that we're going to find the angle between. That's the angle between. So we're going to say that GLM vec2, we're going to get the dot, and the dot is going to be equal to a util dot. I got a util function for that. I'm going to take the left-hand vector and the right-hand vector. So left-hand side is going to be the attack vector, and the right-hand side is going to be the normal, and we're going to get the dot product, whatever that is. And why is this giving me an issue? No viable constructor. Why? That should work. That should totally work. What is happening? It says that candidates consider GLM Precision Tech 4. But I'm looking for those. Look, GLM Vec2 on both sides. So no. These are GLM Vec2s, right? So, I mean, literally, I can just plug in this part here. But I'm just curious because could be the name, but I doubt it. Let's just use auto for a second. I'm just curious to see what I get here. So if I go auto and auto, that's what it worked for. So if I go here, you can see that this is a GLM Vec2, and here GLM Vec2. So that totally should work. Util dot. The other thing is that if we don't want to use this, we can always use the GLM dot. So GLM dot, GLM dot. What? Let's try that again. GLM dot, and it takes two of two types. So I'm going to say attack vector and normal. So why is that not a thing? And what if I just take this away and make it an auto? Oh yeah, that's right. You don't get a GLM vec2. You get a float back. Dot product is going to give you a scalar, not a vector. All right. So let's use my util. So I'll say util dot, and util dot will still give you a thing. This will be a float, and we can make these back into GLM vec2s. That's right. Okay. So now that we've got this part, we want the angle, right? So how do we find the angle between, now that we have the attack vector and we have the dot product? If we take the attack vector and divide it by the dot product, we get the arc cos of that. So it'll be like this: float angle is equal to the arc cos, a cos, of the attack vector divided by the dot product, right? And we want to take this value, these two things, the attack vector, the magnitude of the attack vector. That's what we want. We want the magnitude of the attack vector. So util magnitude of the attack vector. It's got to be one of these. There we go. And then we want to multiply this by util deg to rad. Oh, sorry, rad to deg. Rad to deg. Because we're going to get our radians back. So this is going to give us the angle between it's going to give us the angle between the attack vector and the dot product. Dot product is going to be say where we got hit, and the angle is going to be what's the position of where we're getting hit. That's the angle. So now, before we do left and rights and all that stuff, let's just show what this angle is. We're going to do a standard cout, where we say the angle is going to be angle and then just run this. It'll only come up when we get into a collision. The rest of the time it will ignore. We don't want to do this every time. We just want to do this on collision only. So when it collides only. So, okay, it says angle, not a number. That's a problem. Angle, not a number. This is collision with the ship, but that's a problem, right? So what did we do wrong? Why are we getting a nan? Nan is always a bad thing, right? So first of all, what is the attack vector? We can kind of break this down. We'll leave this here for a second, and let's see what we're going to get here. So first, let's try doing a couple of things. So we're going to say that the attack, what is the attack vector? So attack vector. Okay. So we want the x, and we also want the. So this is the x. Attack x. See if we get values. Is what I'm saying, right? Otherwise, what's the point? And then we're going to go to attack y. We're going to see why we're getting this problem, right? Okay, so attack x and attack y. Let's see what we're getting. We're getting values. Because if you don't get values, then I mean that's the first part, right? So perfect. It's going to get hit, and then attack x and attack y is -4. Attack x is 5.5 and -40. Well, that makes sense because it came from up here, right? So -40. Okay, let's try it again. So it should be minus because we're subtracting. Here we should get a 36 and 14. That means that it's to the right because x is positive, it came from the right, and 14, y is 14, which means it's below. That's to the right. Right? Again, x is, try this again. Alright, so again, we get from the bottom, x is 13, right? So 13 to the right, and 40 to the bottom. Be the same. Okay, x is negative because it's to the left, and y is 6. Alright, so it kind of tells us where it is.
So x is negative from the left, and x is positive from the right, and y is negative from the bottom and positive from the top?
Let's try that again. So y is negative from the top, right? Y is negative from the top and positive from, and also negative. Let's see from the bottom. Yeah, y is positive. So when it comes from the bottom, y becomes positive. We get a positive y value.
Well, it makes it easy to check to see if it's bottom right, bottom left.
That's right. So that's the first thing. So that's what this does. So this attack vector basically tells us the direction, and that's what this is, the direction of this. Now the normal is 0 and -1. What is the dot? Let's do the next check, because otherwise we can't move on without this. So we're going to do dot. What is the dot product? Dot of this. And let's run it. Again, this is all going through all of our checks, right? So we're going to try and figure out, we're troubleshooting why we're getting an N. Alright, so dot is 40. It doesn't make sense. That doesn't make sense at all. Not at all. Minus 20. Minus 39. Okay. So we're getting a dot that is, let's try that again, and let's see what that means for us, right? Remember, the dot kind of gives us a indication of where it came from. So this dot of 40 again. And it was actually not quite right. So attack was minus 40, a dot was 40. Attack was 28, dot was minus 28. Attack was 36, right? Right? And that's where we're getting a weird value. Let's also do this. Let's check it. This is my dot, right? Just to be clear, let's use GLM dot, because we also have GLM that we can use, because we can swap that out. I want to see if it's the same. That's all I'm saying. I want to check to see if my dot works the same as GLM dot, because GLM dot's been proven, right? Mine I made. Minus 13. Okay. Yeah, I want to make sure. I think it's going to be right, but I want to make sure if the dot is right, and if we're actually using the dot properly. Dot GLM. What did we do different? So we used between the attack vector and the normal, where the normal was 0 and minus 1, x and 1. I'm just going to check my previous project, just because I don't want to wipe that out, right? Because I did have this inside of my collision manager. I just don't want to have an issue with it, because I want to get this part right. And let's make sure I got this right. I did it slightly differently over here. I did 0 and 1, vector between, and dot of vector and ref. I kind of did that right. Okay. 8 cos of dot. Oh, it's the other way around. That was wrong. So dot divided by magnitude of vec. That's where I did it wrong. Okay, so dot divided by magnitude of ref. So this 8 cos is dot divided by, the other way around, it's dot divided by the magnitude of the rec. Dot divided by this. Okay, and let's just go put my dot back, because it's identical, and I don't want to use GLM if I don't have to. Alright, there we go. So that should be the angle. Let's see what the angle is. It should give us an angle in degrees, because this converts it. Alright, let's see what that happens, and bam, we get an angle of 56. What does that mean? We're going to talk about that in a second. Alright, so an angle of 162, right? And also we look at these values, attack x and y, right? So you can see that 36 and minus 8, the dot is 8, and then the angle is 77. Angle is 123, right? So it's coming from the top. So again, it's 106 angle. So this is going to come from the top now. So from the top, the angle is 8 degrees. So that makes sense. It's closer to this line, to the middle line. 8 degrees, okay? From the top. And let's do this way, this side. Also, okay, so slightly different. So 32 degrees, not quite 45. Should be 0, yeah. If it was directly on top. But it's going to be rare that you have a direct hit on top. Let's try it again. Let's try the from the left now. So from the left, top. Left top angle is 78.8. It's kind of left bottom. Make sure, because we want to make sure the angles are all right, right? I'll wait till that comes down this way. Again, we're just checking to see. Okay, this is the left bottom, angle 115. Makes sense because it's to the bottom, but not quite this bottom. It's this little corner right here, right? Oh, sorry, my silly movement. All right, so this is the bottom. This left quadrant here. Does that make sense? 131. Yes, because it's less than 135. So the way it works is, let's go back to the picture. How it should work is that each of these angles are the things we're watching. So we want to make that, so this is 45, right? And we want to do it again. So 45. So this is also 45. And then it's 90. 90's over here, right? And then we're going to go 135, if I'm not wrong. So 45 and 90, basically. The angle between. So this is 135. And then the bottom angle is going to be 180. We're never going to see 180, chances are. It's going to be tough for us to see 180, right? And again, I'll fill in the other ones. 135. Just that we have an idea of what we're looking at, right? But you get the picture, I think. Okay? And the top angle will be 0. Kevin helped us with this. He was very nice enough to help us, so that's what we're using. Kevin's methodology. Yay to Kevin. So, again, if you look at this, this is the angle. So what we're saying is, if, let's suppose this, I have a, see my little symbol here? Let's suppose I have the ball that hits this top part right here, this part, then what's going to happen is, it's going to be between the angle of 0 and 45 degrees, right? If, however, it hits here, it's going to be between 45 and 90. If it hits here, it's going to be between 90 and 135. It's between here, it's going to be between 135 and 180. And the same thing goes with these cases on this side. So there's really 1, 2, 3, 4, 5, 6, 7, 8 cases that we can kind of deal with on this side, right? Not including all the exact cases, which is, for example, 0, 45, 90, 135, 180, 135, 90, and 45. Like all those ones, right? So there's all those cases. So lots and lots of cases. For example, I can have one that comes exactly at 90 degrees, then that's a case, right? Because now it's going to bounce back the other way, right? So those are all possibilities as well. So how do we deal with these possibilities? And that's the next part. So we've got the data, right? And let's just get rid of some of this stuff. We're going to keep the C-outs just to help us troubleshoot, okay? And I want to put it in so that way we have just another C-out that tells us this is the beginning, this is the first, attack kind of stuff. So I'm just going to use a separator. So we're just going to kind of do one of these, which is, this is going to be one part. Just so we can separate each of the attacks on our ship, if this makes sense. So every attack is going to look like this. So again, if I was going to do it, what you're going to see is the following. So again, ship not moving very fast, bullets are coming, they're completely missing me right now. But here's one. Oh, that's funny. Right, so attacking the ship, it's collision, and we have this collision, and it looks like this collision and that collision. You can see that the x-coordinate was the same in this case, but the angle of attack was very different. So if we look at these two cases, 113.858, right, and going back to our drawing for a second, 113 was in here, right? So that is like the bottom, that is the right, on the right, and then bottom. Right bottom. And this is bottom right. Right bottom, bottom right. Okay, two different cases. This is top right, and this is right top. Right, two different cases. And this would be obviously right right, top top, bottom bottom, and so on. Okay? So if we see that, bring that up, you can see that those are the three collisions we've had. We've had different angles. 170, wow, that's right almost at the bottom of the ship, right? And we've had, but no other collisions somehow. Okay, let's see if this one's going to collide with us. Alright, pretty good. 167 coming from the bottom. But now, take a look at this. The values we also want to look at is 9 on the x-axis and 40 on the y-axis. 9 and 40. And dot was minus 40. Dot was 1.6. Right? So these all have meaning, and we got to make sure that we use them all. Right? So here we go again. You can see that the dot was negative 0.5. The angle was 90. Ooh, that was weird. How do we get an angle of 90? That I've never seen before. Let's try that again. Angle 120. Let's make sure that we're correct. I just want to make sure we don't mess up here. 97. That seems off a little bit. Don't you think?
I actually think that would be on. Like, try this one, and this one.
Alright, so that one was an angle of 57, because I hit up here.
If you get the tip touches the top, that would go down.
Angle of 38. That looked right. Angle of 127. Okay, so it looks not bad, but we get these other values. We got like dot products as well as things. So let's see what this means. So if we go here and we get a dot product that is 7, an angle of 78, and an attack value of minus 7. Attack of minus 7. Sorry, my wonky movement. Alright, so again, an attack of 36, an attack of 38 and 24, so positive attacks, that means bottom right. Right? Again, positive on the x-axis and positive on the y-axis, bottom right. This should be the top. Positive on the x-axis, negative on the y-axis means top. Negative on the x-axis and positive on the y-axis, that means bottom left. So these attack values is what we want. We're calculating that by getting them, we're subtracting one from the other. Alright, so knowing that then, and if I go back to here, if I know that this is these x and y values, attack vector x and attack vector y, if we know that these two values give us positions, when attack vector x is positive, what does that mean? It means that the object is to the right of my ship, right? If attack vector y is positive, it means that it's to the bottom of my ship. So right and bottom. When these are both positive, then we're subtracting something that's greater. And to check this, the attack vector, because we're subtracting the object from the ship. So this is from the bottom. We should get a positive y, right, and a positive x, because there's slightly to the, this should be a negative x, right, and a negative y, because it slightly came. So we know when this is. This is good. So we can use both values. You can say that when y is negative, it's coming from the top. When x is negative, it's coming from the left. When x is positive, it's coming from the right. When y is positive, it's coming from the bottom. That's what we know here. So this is what we can do here. Our dot product helps us figure out our angle. And so we have a lot of information about what we can do. Great. So now that we know which side we're going to be attacked from, we want to know that when x is positive, so when it's coming from the right, and when y is negative. So again, let's look at the cases here. So here x is positive and y is negative. Y is negative from here, x is positive, right? Negative. So y, again, y is negative, up, and x is positive. And x is positive to the right, right? This one. Yeah, but here is where y is positive, right? And x in this quadrant, and x, y is negative in this quadrant. Let's just write this down. So y is negative, right? And where x is positive. And actually we can write this a little better. We can say negative y and a one line and positive x, like this. Negative y, positive x. And if you want to put it in terms of x and y's, positive x, negative y. Positive x, negative y is here, in this quadrant. Positive x, negative y, right? And then down here is where x is positive, right? And y is positive. So positive x, positive y. And that makes sense because that's how way we draw stuff. We draw it down this way. And now we can say that, well, this is negative x, positive y. Negative x, positive y. And this will be negative x, negative y. Right? Negative x, negative y. That's right. So this is what we want to do. We want to say when x is positive, right, and y is negative, we want to check to see that if the angle is less than 45, right, that means it's going to hit somewhere in here, that we want to make the ball go, it's going to hit this. The angle is going to, the y is going to reverse, but the x is going to continue. All right? So let's make that check. So now we're going to say that if, again, going back to this, x is positive and y is negative. So if attack vector dot x, right? If it's positive, if it's greater than 0, right? And for attack vector dot y is negative, is less than 0. So that's the and this is the top right case. When that's true, and if on top of that the angle is less than, we'll say less than or equal to, just to make sure we cover that basis, less than or equal to 45, then what we're going to say is that every time that it hits, we're going to change the velocity. We're going to say that object 1 dot set velocity, a new GLM vec2 object, and it's going to be where the current velocity, so again, it's here. So the x is going to continue, so object 1 get velocity dot x is the same, but the y-axis, object 1 get velocity dot y is negative. It's going to actually, it's going to reverse whatever's happening here when the angle is 45, less than or equal to 45. Else, if it's some other angle and it's up there, and the angle has to be, we want to be clear, else if the angle is greater than 45, right? So greater than 45 but less than 90, right? Because it's still in this quadrant. Well, the reality is that we shouldn't have to check for that. We should just put else. because it'll be the other angle, right? So then we can say if it's the other angle, then
So the only reason it's in this check to begin with is because the X.
we're here, yeah. And we're only going to check one at a time. If it's the other angle, if it's this angle up here, what we're going to do is we're going to say it's going to come here this way, right? And we want to go this way. So it's coming down, and we're going to continue going down, so Y is not going to be affected, but X is going to be reversed. So we're going to say, X is going to be reversed, oops, but Y is not going to be affected. Let's just check this one and see if it works.
I think that's what we were doing wrong earlier with the area, like when I just walked in.
I don't know.
Putting a positive one.
Let's see what happens.
Now
Right.
you're dealing with it.
Well, let's see. So one thing at a time, right? We want to check to see if that's the case. So first of all, we shouldn't get a bounce here, right? Because we didn't account for this case. We want to account for this case up here, like this one. Here we go. Okay, kind of worked. It kind of worked. It kind of hit this part here, and it kind of went this way, right? We didn't reposition anything either. We haven't done the repositioning part. That looks pretty good. So it came from this way and went this way. Now we want to find this one. Let's try this again. Looks like it's working okay. And let's do the other part. Now this one's not going to bounce because we have no case for that. And okay, this is good. This is a good angle. So let's see if we can reposition this. Yeah, we're good. So that worked great. So that looks like that top corner we've covered, right? Because now that top corner we're good. Alright, so now that we've got the top corner down, let's keep going. So we know that if, on the other hand, attack vector, right, dot x, and again, we're looking at this diagram, if attack vector dot x is positive and y is positive, so in this case, positive 0 and attack vector dot y is also greater than 0, right, then this is bottom right, right? If that's the case, then we want to do another thing. If the angle this time is, we're going to use the same thing, is less than or equal to 135, so this part right here, then we're going to say that, so if angle is less than or equal to 135, then what's going to happen? We need it to do something like this. We're going to say that the less than or equal to 140 is going to go here, so it's going to come this way or this way. So the y is going to continue, but the x is going to be reversed. So y is going to continue, x is going to be reversed, which is this case. Right? Y is going to continue, x is going to be reversed. However, else, it's the other way. Else, if it's this one, then y is going to be reversed, x is going to continue. So y is going to be reversed, x is going to continue. This one. Make sense? Let's try that case now. And this is bottom right. So run it. Hopefully this will work. And again, we want to try one thing at a time because, so this we know is going to work because we've already checked this case. So let's just do the next one. Okay, here we go. Oh, damn it. My movement sucks. Bounce, that's good. Too far away. We want another one from the bottom. That's what we want, a bottom right one. So we can kind of match. Let's check the top one again. Pretty good, pretty good. I'm pretty happy with that. That didn't work because it came from the top left. That's good. And how about this one? There we go. That looks good. That looks good. That looks really good. Right? And let's take a look at the... Well, that's good. No, that's good. That's all good. It's all good. It all actually worked okay. Same thing. So that worked okay too. Right? So it looks like this case is solved. Right? Bottom right. Let's do the next one. Top right, bottom right. We want to do this part. Minus negative x and positive y. Right? So again, we're going to go if attack vector dot x is less than 0 and attack vector dot y is greater than 0, so that's the case. So this is bottom left. Then what's the angle we want to check? If angle is Again, this is where we get a little squirrely. So again, is it less than or equal to 135? We can do that check, or we can do this way. Let's check less than or equal to 135. I'm just going to copy and paste and see what we need to check. So if it's less than 135, then if it's coming this way or this way, then the x would change, but the y would stay the same. So x would change, y would stay the same, and then this one would be reversed, right? Where if it's coming from this side here, y would change, x would stay the same. Y would change, x would stay the same. Alright, so that's that one. And let's keep going, because I'm confident we can keep going. So negative x and negative y, let's do that. So again, if attack vector dot y or dot x is less than 0, and attack vector dot y is less than 0, this would take care of the top left case. Then we can, actually we already have this, right, which is up here. Let's just take this part and check it to see if it's the same. So let's see if that's true, right? By the way, we can combine some of these later, right? Like if this is the same as this, then we can say this case or the other one, right? And we can make it only two cases, right? Which is what I was hoping to do. So this is top left, so let's check to see if this is true. If angle is less than 45, so that's in here, then if it kind of bounces in here, if it bounces, then the y is reversed, but the x continues. So y is reversed, x continues, and so on. Okay, so it looks pretty good. Let's just check now and see what happens, trusting that we've done things properly. Now we may have some reversals, and we'll see what happens with that. So that's pretty good. That's bottom left, and that's pretty good. I'm happy with that. Completely happy with that. Right? And that's too low. We're not going to catch that one. Maybe this one. Yeah, we got that one, and looks pretty good to me so far. That's perfect. Nice one, right? Yeah, I'm pretty happy with this so far. There is a couple of edge cases we haven't taken care of, and we're going to talk about them. Right? Are you happy? I am. Worked on this all day. You know, and again, it would be the same for you guys, right? Now, luckily we had some pretty good help, so I think we were able to accomplish this. Now, we want to combine this, because look, you can see that these are clearly the same cases, okay? Like this one and this one, clearly the same. So bottom right or bottom left, it's the same exact situation. We're this exact same angle, right? Doesn't matter which one or the other, if it's either one or the other. So we can try it. Take this one here. This is the bottom left, and we can, you know, put an or in between. So we're going to say or, right? And we're going to basically do one of these, and we're going to comment the other one out because it worked. Okay. So this is case bottom right or bottom left, right? And we're going to comment this part out. There we go. And that's this part. And we're going to do the same thing, because this part covered both bottom right and bottom left. And this is top right and top left, which makes sense that it would be the same, right? So we're going to take this condition, and we're going to put it over here. So, or, undo. I don't know what happened there. Love that undo, man. Imagine back in the day we didn't have that undo. Yeah, top right or top left, right? Redo's pretty awesome too. So we're going to get rid of all this for now, right? And these two cases should be all you need, which is what I was trying to say earlier today. But let's check to see if that's true, okay? Because remember, we're trying to simplify here. We're refactoring a little bit, only because it's pretty darn ugly, right? So, that looks pretty good. Right? And now the real test is going to be when I add like 50 bullets. I'm not joking, I'm going to do it.
Do it. Okay, sweet.
But let's check if all the cases are good first, and then we're going to do it, right? Because now there's going to be some tunneling. One thing we haven't done in this whole thing is we haven't repositioned. Because sometimes what happens is, depending on the speed of the bullet, you're going to get tunneling. You're going to get, you know, kind of penetration, right? Which is what we don't want. But that was because of the way I came at it.
Right. Oh, that's because it was coming up and then you came at it.
I came at it from the bottom, yeah.
Yeah. Yeah, exactly. Damn, that's such a good movie. That's so underrated. It really is.
Alright, so this totally works. That means I can subtract all of this, right? Let's put this up on GitHub now that we have it, so we can always go back to this case. So this is the case we need to put in, right? So we're going to go, and we haven't even talked about widths or anything. We didn't have to do that. So let's put this up on Solution Explorer. Let's go with our Team Explorer. I'm going to go to Home, Changes. I'm going to say added collision response for bullet and ship. Home, sync, and push. We didn't. Did we unmoor that? We did. Damn it. All right. So that pulled it up. That did all the stuff. Now let's do the real test, and this is the final thing for today. So if you bear with me, we'll do this. The final thing for today is let's add like tons of bullets and see what happens, right? So enough bullets where we can really test this thing. Let's see. Let's see what happens, right? So how do we do that? In my start scene.h, really quickly, instead of making a bullet, each bullet, we'll make a vector of bullets, right? We'll call it bullets, right? So again, it would look like this. We'll say that we want to make a standard vector, right, of bullets, targets, right? I'm not wrong. We'll call this one M_P bullets. All right, so that's an array or a vector of bullets, right? Now we gotta load up a bunch of them. I'm just gonna uncomment this one or comment this out for now. So it'll give us an error. I want the error, so we can see what we need to replace these things. Okay. So let's go back to the top here, and we can see that we want to draw all the bullets, but before we get there, I want to create all the bullets. So start. In my start, where I instantiate them, I want to do this, but I want to create all of them, right? So remember, what I want to do is I want to do a for each. Let's do a for each. Perfect. That's not what I wanted, but the element is going to be, and we're going to use auto here for a second. I'm going to say auto, and I'm going to call this the bullet, right? In the collection M_P bullets, right? And if you look at the type, it's going to be a standard vector of target star. That's what it's going to be, right? So that's what each of these is going to be a bullet vector or a bullet pointer. And then what I want to do is I want to make a new bullet. So bullet is equal to a new target. So I need to instantiate. I need to allocate memory, right? And then what I need to do is reset it. Bullet reset. So I'm going to reset it back to where it's going to be. And then what I want to do is I want to add it to the bullets array. M_P bullets, right? Actually, this is kind of wrong. What I meant to do, this is right, but I want to push back the bullet, right? But bear with me while I do this for a second, right? We also don't want a memory leak, right? What this does is it makes a new bullet that I push back to it, and it creates it kind of on the fly. So basically what I would do is I'd make a new bullet of type, I'd make auto, I'd say this is auto bullet, blah, blah, blah. But I don't want a for loop. Let's say, how many bullets do I want? Do I want 50 bullets? Let's make a for loop, not a for each, because we don't have a for each left. So for, what the? Thank you. Yeah, so we'll make it I. Maximum will be, what the hell? That's weird. That's a backward count. That's wrong too. Okay, that's better. All right, so yeah, so my upper value is going to be, let's say, 50 bullets, and then plus pi. Sure, we don't mind that. And we're going to say is that we want to do this every single time. So for every bullet, we want to add one, and we want to get rid of this for a second. Actually, we'll just cut this out because I'm going to use this in a second. So I add a bullet. And then what we want to do is we want to delete this bullet, because what's happening is if we don't delete this bullet, right, we're going to have a bit of a memory leak. So I've created one, and then we're using a raw pointer here, right? So we want to try and do some deletion. So I could say something like, you know, delete bullet. I'm going to definitely do that, and we can set our bullet equal to null pointer, which is going to help us with that. We don't want a dangling pointer either, so that'll help us with that, right? That will do it. What?
Instead of delete it right away once you create it, or do you have to delete it after it leaves the screen?
Actually, we're making a bullet that's temporary. That's what we're doing. So we're making a reference. You're right, actually. If I do this, it'll delete it before we push it back. Let's not do this for now. There we go. So we'll have a little bit of memory leak. It's okay. Yeah. So we instantiate a bullet array of bullets, and a vector of bullets. That's what we're doing here. A vector of bullets. So we instantiate them. Now we have to update them. So inside of our draw, right? We're going to do for every bullet and bullets, however many bullet and bullets we have, we're just going to draw it. So we're going to say that bullet draw, right? Draw the bullet. So every time we want to go through it, we draw the bullet. We're going to take this again, and we're going to go into our update. This is where it gets tricky. We want to update the bullets. However, this is where it's going to go crazy. We're going to have to do a circle check with each bullet. So we're going to take this part and we're going to cut it and put it in here, where we're going to say this is the bullet that we're checking. And that's where all the checks are going to be, the collision detection, right? Are you unsure about this working now? Don't be scared, man. Don't be scared. Let's see what happens, right? The point is we want to try and experiment here, right? So let's see what happens. We have 50 bullets. We're just going to press the button and see what happens and let it blow up. All right. If it blows up, it's in a safe environment. Okay. We're not going to destroy Europe with the 50 bullets. Okay. Don't worry. Worst case scenario.
Oh, what's that great war game? That great
oh man.
Oh hell yeah.
It looks pretty good to me. Okay, well there's some penetration,
yeah,
but we got pretty good stuff. They don't care about bouncing off each other, right? But it looks like it works well to me, buddy, and there's no lag. One thing we will get though.
There's this slight slicing that if it comes
it
at
happens
a perfect
sometimes.
angle,
Yeah.
it's like slicing.
All right, well that's good. Let's get rid of some of those comments now, because there's a lot of comments in this thing. So we can get rid of some of these, like this stuff here. We can just comment this out.
Oh yeah, 50 bullets each thing.
Yeah, that's a lot of comments, right? So we're going to comment those out. Yeah, hold on. So I'll show you what I did, and then we'll stop, because we got to stop for the day.
Man, what a great lesson though.
But this is going to give you everything you need. Should need for everything you need. Then you can just add velocity, right? Which is something I can't cover all the time. All right, cool. So bam, It does it, and I can see that. Let me just make sure there's no other. Oh yeah, collision ship. Let's get a stop too. Okay, so this is the problem. See that? That's a really weird. But that happened because it came at such an obtuse angle. There's a case we're not handling.
Right.
Right?
So it came at the perfect angle.
Came at the perfect angle. We're not handling that case.
Yeah.
Well, this is what we should do. See, and if I move my ship, right, it's going to go through them and tunnel because I'm also moving. Right? So it's not repositioning. We're not doing the repositioning part yet. Right? See, there's some parts that, like that one, like where it came at the exact angle, right? And that one too. It happens. So what's left to do? The reason why this isn't working 100% is because it's not repositioning. And also it's moving. Right? Look at that. Like that's inside there. So we've conquered some of it, but the stuff that you're missing, yeah, that's pretty awesome. The stuff that you're missing, that's on you to do, right? So this is my to do, but yours to do is this. You're missing the repositioning part. So we've done the collision detection. We've done once we do the collision detection, we've done some simple collision response. But now we need to do repositioning. And repositioning means at the angle of attack, we need to reposition the bullet back to where it's supposed to be, right? Because sometimes what happens is it penetrates.
Right.
Right? And we never want to let it penetrate. Also, we have a moving object. When we move our ship around, we have a moving object, and when the ship moves and the bullet moves, we're trying to calculate stuff at the same time, which also lends to it having a problem, right? So again, there's more work to be done here, but this is a great beginning, right? So
what do we want to have occur in the repositioning? Do you want to be repositioning the ship or the bullet? Like, sorry.
It's the bullet.
The bullet.
Yeah.
Okay.
Because the bullet itself is what we're moving, right? And again, if you look at that lesson that we covered, so if I go back to lesson number 10, this one. And if we go back to that collision response thing, which is, let's just make it view, a regular view, normal view. So I think it's way down in here. Impulse approximation. I know, there's a lot of stuff, eh? Center of mass. There we go. So if you look at this, and if you go through, it talks about elastic bouncing, which is what we're kind of doing, right? But the challenge is, it's this. So you have the bullet, and it penetrates through the wall. Why? Because what's happening is every frame, you're trying to detect the collisions, right? And now there's enough bullets that you can actually do this collision detection check, right? It's not just one. It's tons, there's 50 of them. And this is great, but what's happening here is that you're getting some penetration here, especially since you're pushing into the bullets, right? So there's two objects that are pushing into the bullets. One, and the ship is pushing into the bullet, and when it pushes into the bullet, well, guess what happens? The bullet goes into the ship. And if the bullet is inside the ship, it needs to be repositioned and pushed away from the ship. And this is where, if we're going to do some repositioning, we have to kind of sit there and say, there's got to be this, like, radius, if you will, right? Which is the width and the height of the ship that the bullets cannot possibly pass. When they collide and they're going to rebound, right? What if there's another collision immediately afterwards? Like, how do we deal with that, right? Or if I keep pushing my ship into the collision, I'm actually trying to push my ship into the bullet. Like, what do you do then, right? You should continue to push the bullet away from the ship is what should happen, right? Which is another case that we haven't talked about, right? So we need to reposition the ball in the regular case outside of being penetrated outside in here, which means we have to pull it back around the angle of incidence. We know the angle of incidence because we have the attack angle, right? We just got to push it back along that same vector, the attack vector.
On the x-axis.
Yeah, we just got to push it back, and we're going to push it back width and height.
Or half
Half width, half height. That's what you have to do, to push it back, right? So that's what's going to have to happen. And it talks about repositioning the ball, right? So basically what we're doing is this. We're saying that the ball X is equal to the wall, which is in this case is the ship, X, minus the ball radius. Yeah, minus the ball radius, which is the radius of the object, right? So that's how we should reposition it. And then we've already done this. We've already reversed the ball from a velocity perspective. We've done this already because we have a velocity vector. We've reversed, right? So that's no problem. Same thing when it goes here. It's a little bit more challenging, but we have to reposition it back along the axis, and then we send it back. And then we talked about this. Now we also didn't do on your project. You have to do some kind of energy loss. Here's an example of energy loss, which we talked about, which we can use some kind of energy loss factor to reduce the speed. Okay? So all this stuff was covered, and it talked about, this is a more difficult one, bouncing off inclined walls, where now in our case, we're not inclined. We're just like literally an object that's straight. It's a rectangle. It's a perfect square, so this would be something we have to deal with. One thing we haven't dealt with, which we can do to improve our code, again, is we've kind of checked the positions here. So we said, here's my attack position, my attack vector, right? But we don't have a repositioning vector. So one thing we need to put together is, okay, so we've got our attack vector. Well, what's the repositioning vector? It's the opposite of the attack vector, right? So we have our vector, and that position is to the right, wherever it's going to be. Remember, our attack vector shows us the number of pixels, the difference in pixels between where we hit of the ship. That's the exact position that we hit relative to the center, right?
Of the ship. Yeah.
If our x value, right? If our x value is less than the width, we make it the width. If that y value is less than the height, we make it the height, and so on, right?
That's fairly simple.
Yeah. If the y value is, and depending on where it is, if it's negative, if it's inside, basically what I want to say is if it's inside the box, we want to push it outside the box somehow, right? So if the x value, if the negative x value, right, and the way you do is you normalize it. I'm just talking to it now so you guys know how to do it. Let's suppose that the ship itself is the radius or the width and height are both the same. They're 30, let's just say, right? 30 and 30. And if we get our attack vector, here's our attack vector, and the attack vector dot x is 29, positive 29. We know right away that it's inside of on the x side, right? It's because it's 29, it's not 30. It's the difference between our center and the attack vector. If it's 29, we need to push it to 30. We need to change that attack vector to 30 before it gets down in here, before it gets down to the check, which means that we need to reposition the object, not just the value, but the object. We need to reposition so it's farther away, right? So that means that the object one dot set position, we get a set position 1 pixel or however many pixels to the right or to the left, depending on where it is. So example,
Just have an if statement, right?
yeah, we'd have to do that. So for example, let's say we have our bullet and the bullet is positive x and negative y, but instead of it being here, it's actually here, right? So if we detect a collision like this, where the difference between here and here is less than, let's say, 30, right? Then what we want to do is we want to push the bullet to here, then calculate the attack vector, right?
We need to check for all that.
Yeah. Which is going to happen before this. So it's colliding, but what's the distance? And we know the distance because we've done this. We've done, so circle AABB squared distance, the square distance check, right? If the square distance check, right,
Not the same.
is less than, yeah, it's less than the height and width, it's less than this, right? Because square distance is going to give us a square distance, but we need to find the distance between the attack vector. Like, we have to calculate that attack vector again, right? And then we can push it out. And that's something we have to do, whatever the radius is of that object, right? We don't want to do an actual distance check because that would require square root, right? But we do have a square distance check where we can say if the square distance, this one, like a circle check. Now this is assuming that, by the way, I have to tell you this also, that's assuming that the object is square, what we've been doing. If the object is elongated, now we're going to have a different set of values. We're going to have to add width to the object, right? Because when we do our checks, when we do this check down here, these checks, we're saying that if the attacker x is greater than 0, right, the attack vector, but the attack vector has to also be not just greater than 0, but it's got to be greater than, we have to add the width, right, and the height. So the attack vector that we're getting here is the number between the 2 points. But that's incorrect. It's detecting the border, the barrier, right? But one of the challenges is that if it's very wide, then you're going to get a different value. Right? Because the width and the height are going to be different.
Right.
Yeah. So that's kind of what we're doing here, right? So there's some repositioning to be done. But again, if you notice what we did when we did the final version, it's this. Here's something interesting. Did you notice something else? Did you notice how everything was exactly the same?
Exactly. I thought we randomized it, but there was 50 of them, and they all came in.
Well, it looks like it's randomized, but remember, it's pseudo-random numbers, right?
Oh, so
they're all starting at the exact corners. That's one thing. To randomize it even more, right, and this is because of the target.cpp, what we did was we said, depending on what we roll, they're all going to start outside, just outside of the border, right? But if you really wanted to randomize this, you could make a random value. So whatever the height is plus some other random value away so that they would all coalesce differently. That's why it looks the way it does.
Because they're all going.
They're all coming from, they're all
very
starting
same
off,
spot.
yeah, they're all starting exactly at the same
Yeah.
spot, right?
So it
Later
doesn't
on,
really come in.
they're more random. Later
Right.
on, it's okay. When we run this later on,
Yeah.
second iteration,
Yeah, exactly.
from the beginning it starts like this, and then afterwards you can see that they reset separately because of the
Yeah.
speeds and everything else, right?
Just one mistake that I could find.
Let me just finish recording here. Okay? So that's it for me, guys. Remember, next week you're going to be doing your test. There's going to be something that we necessarily haven't covered in this example, but it doesn't mean that it's not going to be something you haven't seen before, right? So make sure you study. Again, I think I pushed this up to GitHub, but let's just try this out again. I'm going to go to Solution Explorer, Team Explorer. I'm going to go to Home, Changes. I'm going to say added a bullet vector, right? That's what we did. Home, because that we have that change too. Sync and push. Okay, guys, and we will see everybody on Tuesday. We'll do a bit of a review on Tuesday about what's going to be on the test again. We'll talk about the template. I will show you the final version of the template, and then you'll have the test on Thursday.
Awesome. And did I hear correctly earlier you saying you change the assignment?
Yeah, the due date.
Next Friday?
Yeah, that's a good point. So the due date for the assignment is next Friday. Not this Friday, but the final week of class,
Right.
Friday. So it gives you lots of time to fix this problem.
That's the second bump you did, right?
That's
You did
second
it
bump, yeah.
Sunday,
Yeah, yeah.
And then a bunch of people
Yeah.
talk to you. Okay,
Yeah,
cool.
yeah. They need more time, so it's fine.
Well,
All right?
yeah, appreciate that. Thank you.
Your assignment 3. Your assignment 3 is due December 13th. No.
Yeah. Not.
Right.
What? Yeah.
Yeah.
So just take it.
Okay, so we'll talk soon, guys. See you next. See you. I know people are happy. We'll see you guys on Tuesday.